Hi, I'm Pacata12, and today we play with the most beautiful algorithm, and that is substrate done by Jared Tarbell in 2003. And I will leave a link in a description to this article, and also a wonderful Aris talk in which Mr. Tarbell is showing some of his work. Wonderful inspiration. So we'll recreate this from scratch using only tops. Let's start. We'll recreate the network you saw. So let's start with the constant chop. And here we set the resolution X. 180, let's go with that for now. Ratio, it's 9 divided by 16. And the seeds. And let's start with 5. Okay, now I want to make a folder, so let's have a null. Insert another null in between. Collapse selected. We don't need this null. And I name this data. Okay, inside we select resolution X and ratio, and we need a rename into resolution Y. Now with the math, we go channels divide, a merge here, and also let's update the ratio. So we select the resolution X, we rename it into ratio, and now with the math, we drag the resolution Y here and we say 1 divided by, so like that. And now we have the new ratio, which in this case it's similar, but yeah. And we set replace first with last. Let's go outside. And we need 5 seeds, so let's have a base. We call this seeds. Let's go inside. Inside we need a noise top. We set the resolution how many seeds by 1. This is 32 RG, nearest pixels. Okay, we go with random GPU and not monochrome. And now let's use a null. We name this position. And also here we use a math and we solve the ratio. Now this math is red, as it only modify the red channel. We mask the green and we multiply with the ratio. Okay, now let's have a geometry here because we want to instance those points to see them. Okay, inside I use an add sop. Now we have a point, we convert this to particles. So from polygons to particles per point, render as point sprites. Turn on those flags. We are ready to instance. Okay. And now let's drag this RG. Now we need a camera, but I'll put the camera here in the parent. Because we'll use it in some other place. So here we have a render. We use the camera from the parent. Okay. And let's set the resolution we have. Okay. Now let's have an out. This render, it's mono, nearest pixels, and not anti-alias. Okay, now select everything, nearest pixels, and now we're good. And yeah, we don't see the points. Let's go inside here. Also use a material, so point sprite material, and now let's use it here. Okay, now we see the points. Let's adjust the camera a little bit, because this camera needs to be orthographic bottom left. Let's drag the ratio here in ortho with it, and now we have 5 points. We are good. Let's have a last null here. We call it final. Again, nearest pixel, and we want to watch this here, so top view. Okay, now we have 5 points. We need 5 directions to go, so let's have a noise here, and I would like to insert a null here, and name this seeds update. Okay, I will make this purple. Okay, now let's see. We can either go in this noise with multiply. Let's set this is 32, not monochrome. Okay, if we go multiply, we see only 5 pixels, and actually we don't see too much, so I prefer to just take the noise, the resolution, and then we multiply like this. Okay, I prefer that while I'm working. So now we have 5 points, and they have a direction each, but let's normalize that direction to be equal for in distance. Okay, so let's have a null here, insert a null in between, collapse selected, normalize. Okay, and now we have this. Okay, let's solve the normalize. Normalize is nothing but a composite with divide. Okay, and here it's math with Pythagora, that it's length, mask the alpha. This is 32 mono. Okay. Okay, now you notice the pixels become much brighter. Okay, here in this component divide and transform input 1. Okay, so we have brighter colors. That means the length it's big. But what we do with this is we displace a new V. So let's build a new V. Let's drag the resolutions. Okay, we use this for the color, for the resolution only. So, but anyway, let's make it black. Okay, and now we have a null. Insert a null here in between, collapse selected, and let's name this UV. Inside we need 2 ramps. Okay, so ramp, set resolution only, is mono. Okay, the second one, it's vertical. We connect both of them into a reorder. Okay, let's take input 2 for the green and set this resolution to be 32 RG. Okay, select everything, nearest pixel. Okay, now that we have the UV, let's correct the ratio with the matte. And we make this red because we drag the ratio and we multiply with the ratio. Just a second, I reopen this again, this window. So I drag the ratio here, but mask the green because this only takes effect on alpha. Okay, now what if we use this place like this? First of all, let's set green here and the source midpoint it's 0. Oh, I deleted the final. Sorry about this. Okay. Now green here, midpoint it's here. Now we see our points, but let's clean the texture a little bit. So I use a null, collapse selected, clean. So I will see the network here. Inside this clean, I want to drag this seeds update, okay? And I multiply the incoming texture, okay? Now the background is 0. Reorder, I want to set the alpha according. So input 2 takes the red for the alpha. This texture is RGBA. Now select everything, nearest pixel. Okay. And I have a null here. Let's call it position. I make it pink. And now I will steal this geometry and place it here, okay? Now you see where our camera goes now. We have another render. And this one takes this geo and the camera and the resolution. So, okay. And here let's go and set active to alpha. Okay, now let's go back to, we don't see anything, right? And this is because this vector it's way too big, so let's use a matte. Let's use a matte and divide this by the biggest resolution. So in this case, 1 divided by resolution Y. Okay, now you see the points. Let's go here. They are not moving, okay? To make them move, we need to sum this little direction over and over. So let's do that. I'll take this constant. I use a feedback. Okay. Let's go also with the keyboard in to pulse and reset this feedback like this. Okay, and now I want to add this little vector and then I bring back the add into the feedback. Okay, now the points are gone and we can make them stay inside the screen. In this displays we set repeat. Okay, now let's go in the render. This is 32 RGBA, nearest pixels, and not anti-alias, okay? We don't know yet if it's correct, so what I like to to use its feedback. So we have this feedback. Let's go inside. We don't need this dry wet part. Okay, so I delete this. Here in this level, let's go with unclamped. Select everything. Nearest pixels. Okay. Now we set the opacity to 1 and also use this keyboard to reset. Okay. Now let's see the lines. I will make everything nearest pixel again. Okay, let's see the lines. Now, yeah, you could saw for a moment something here. You have those points appearing, you see, and this is because of this interpolation in the display. So we go with nearest pixels. Now the lines seems good, but I'm not sure, so I will use a constant, and I have my own directions. So let's go to the right. Okay, 1 on a red, and let's make this texture RGB. And if we connect this, oh, just a second. Constant, set resolution and output noise. Oh, so sorry about this. So not the noise. Okay. You see some gaps that are strange because sometimes you have gaps, sometimes not. So let's go in this place and drag the ratio for the display's width on red, and we multiply with 1 divided by, and let's check now. Now the gaps are there, but they seems equal. Okay, last check, 45 degrees, and now we half the direction. Okay, now we good. We don't need this constant anymore. Okay, we have the lines. How can we make them stop? Okay, now I want to select their direction because we use sensors. Sensors is when you check your next step, where your next step hits. Okay, so for that I would like to take the normalized vector. So inside this component, okay, I select that component /out1. Now we have the direction normalized. We use something similar with this math and decreasing the length to 1 pixel. Okay, like this. And now I want to add this over my points. My points are here in the pink texture. Okay, so now I have, let's switch the inputs. Now I have my sensors. Okay, this is good. Let's use a math. I want to prepare this texture to be in between 0 and 1. So let's stretch it on red by 1 divided by the ratio. We mask the green, we make this red, and now we are ready to remap. So remap like this. Before, let's go here and set reorder, and I want to take only the alpha. Okay, and let's go with 32 mono plus alpha, and this remap is mono, and also nearest pixel. Now each time a line hits another line, I should have a white pixel here, okay, in this texture. And let's call this texture, we chain a null and we call it stop. Okay, now let's make it purple. And in order to use this, I want to make some modifications, some adjustments here. So I'll make some room because I want to use that stop. So I can have it here with a feedback. So I have a feedback. Let's make sure this one is black and white because that's the stop texture. I will get this into my feedback. And now I want to use a mate. First, let's have another constant here, an RG0. So I use a mate like this. And now the third input will say from each of the first two inputs the value it's taken according with that white pixel. Okay, so let's set luminance here, and we good. Now let's now have this mate. Okay, now this is the vector. Let's see now if the lines are stopping. Okay, it seems they do. Oh, this is great. Okay, now let's see what else we do. Let's solve the branches. Okay, so the branches. What if we use a method in we spread some seeds, and then the lines there, when the lines hit a seed, then we have a branch. Let's do that. So we use a noise. Let's go with a smaller period, 0.001, and maybe input multiply with noise. You see, now we have a noise on the line, and we use threshold now. And we play with this value, okay? And now let's name this more seeds. Okay, I'll make it purple, and yeah, this is good, but we need this texture to update our seeds. Okay, so that means another feedback. Let's copy this. I'll take in this feedback, I'll take the more seeds. Okay, and now I go here and I use a composite with maximum. Okay, so maximum. Let's see. Yeah, we have branches. It seems that the direction, our direction, it's wrong. So let's set the offset to 0, amplitude to 1. Okay. Yeah, now we have all the directions, and let's use some colors. Colors are super easy, and let's do them. Null. Okay, I name this color maybe a pink, and now let's drag this here. Let's make some room. I will disappear a little bit, so R, G, and B. And we have this, and yeah, we have colors. Now you know why we use this reorder, okay? And what if the colors are keeping the color of the lines where they start, okay? And for that we need to take this texture inside this feedback, okay? Now how we do this? We need another feedback. Let's copy one, and we initialize the feedback with the UV, and now in the feedback we drag this texture. This texture we drag it here by say feedback slash out1. Okay, let's see. Yeah, we have it there. So over. Okay, let's check now. it seems good, but yeah, let's see it much better. So now we use a noise, and yeah, let's have the same resolution, but let's see. So noise, and this is color. Okay, and now we multiply this with the alpha to clean the background. Okay, now we can go here with transform, and maybe set a black background like this. Okay, now we are good. What else we need to do? What if we force the directions? Okay, so so now we have random directions, okay, and we'll force those directions to be only 4: up, down, left, and right. Or maybe you want 3 direction, or maybe you want 6. And we actually build something that I like to call it step angle or quantized angle. So let's insert a null here, collapse selected, step angle. Okay, inside, we go inside, and here we need a reorder. We take the red, we make it monochrome, let's color it red. Okay, now we take the green, so we color green and take the green. And here we use a function, and we connect both of the inputs. Okay, in the function we take arctan input 1, input 2, but let's switch the inputs, okay, because I believe this is correct. Radiance, and now we have a limit with quantize. We go in quantize tab, and the floor 1 divided by 4, and right after we go with the mat. We multiply this with 2 pi, so 2 multiply with mat.pi, and right after we use a function, and we take, for the red we take cosine, for the green we take sine, and this is radiance, and the texture is 32 Rg. And now we have the step angle component. Now let's see how this works. Okay, we reset, and now we have only straight lines, and yeah, this is pretty good. Okay, the idea is how can we make them have different speed. Okay, let's have another noise right after the mate. Okay, so let me make some room. Oh, and we use a noise. Okay, black and white, so this is mono. And maybe 0.5 and 0.5. So we have mostly values in between 0 and 1. Now we use a limit, and we force those to be normalized in between 0 and 1. Mask the alpha, or yeah, we don't have alpha. Yeah, I saw there's something. Okay, now we multiply with this. Let me make everything nearest pixel. And now the speed, it's way better, much better. Okay, and this is good. Let's increase a little bit the resolution. Let's go with the 360. And okay, this is pretty good. Now let's see, before we go to the white background and make some shadings, nice shadings along the lines, it's anything else, it's something else I want to show you. Now you see here where we solve the seeds, we actually spread some seeds and we wait for the lines to hit them, okay? Now the moment they hit the seed, we have a branch there. Now that might be a little bit strange, because would be much nicer if the line goes, and sometimes along the line some branches appear, okay? Now let's do that. So let's set this being the simple seeds solution, and now let's solve something here. So I would like to have, as I said, different seed distribution, more dynamic, and also to not have seeds in other seeds proximity. Okay, so we'll have a distance for the seeds. How we do this? So let's say select seeds update. Okay, you see there are some points. Okay, let's see them. There are some points, and yeah, they come too close. Then we have some lines like that. And what I want to do is use a blur, and let's blur with 8, for example. And now, not blur, sorry about this. So not blur, edge first. So with edge, we go with composite over. Now we have some squares. Now we have the blur. Now a matte with ceiling. Okay. And now let's use a level. We invert this. We can clamp it in between 0, 1 to be sure. And now the white, it's representing the available space around the seeds. Now we multiply this with what we have available for the lines. Okay, so the white space represent the places where some other seeds can go. Okay, and that means we have this noise. Another one. Let's bring another one. Okay, and to not have too many lines, let's set the resolution this way. Okay, and this is mono. And yeah, let's make this moving. Okay, and here in the threshold, now I can play with the value. Maybe I want less, so let's bring down the offset like this. It's how you want. Now those are some points that I want to check every frame if they fit here. Okay, so we multiply them, and what it's white is good. Okay, now I would like to have a feedback. I will copy this. I come here, and yeah, with this feedback we go composite, maximum, and then I'll bring back into the feedback, and now we can connect with more seeds. So let's hope now I select everything and nearest pixels, but the blur, let's set interpolate. Okay, now we're good. Let's see now. Now you see the lines are starting later. They're not in the tip. And this is very, very nice, right? What else we can do? Let's noise a little bit this direction here. 1 divided by 12, let's say, and maybe have this move ABS time dot frame divided by 1024. Let's see. Yeah. And the density of the lines, you can now change this here. Okay. Now you either go with a higher speed, let's say each frame, more seeds will find the good place, okay, and this also affect the speed, right? Or you can play with the threshold, okay, so it's up to you how you want it. And yeah, this blur for spacing works very, very nice. Okay, now what else we do? Let's instead go with the black lines. Okay, so I will have a level here, and in the level I go range out high to 0. Okay, now in this transform, I need to set the white background like this. And my idea, and also the idea of the algorithm, is to draw some nice shadings along the lines, how we do this. So let's copy this render and the geometry, okay? Now this geometry should have lines. So let's set line sop like this on the z-axis. We turn on the blue flags instead of point sprite. Let's go with not constant, sorry, Fong, and we set the constant to be 1. Okay. Now here in the alpha, we need to solve the alpha with a ramp top. So a ramp top like this, maybe 1024 or more. We multiply with 2 by 1. Okay. Nearest pixel doesn't really matter. This mono. And now we use a null. And we drag it here in the alpha, and also I want to flip because it starts with black, so I want to flip the x-axis. Okay, now you see the lines are quite big. Now we need to orient them and also scale them, right? And the orientation should be perpendicular with the line. So the direction for the line is here, it's normalized already. And now I want to find the perpendicular. So the perpendicular, let's have a perpendicular component, insert a null in between, collapse selected, and perpendicular. Okay, this is very easy. Whatever vector you have, perpendicular, it's you use the reorder, and you switch red and green. And right after, you multiply one of them with -1. So in our case, I multiply the red, so mask the green, and I also color this red. Okay. Nearest pixels. Okay. Now we have the perpendicular direction, and I like to call this rotate 2. To match the instancing parameter. And yeah, we have that. What else? Let's have a noise for the scale. So this noise, we call it scale. I make those pink. This is mono. Okay, and because it's from 0 to 1, or I want to scale this down with 1 divided by 32, let's say. Okay, now let's use those here. Okay, we have a scale. We drag the scale and use red for the Z. Now they are so small. And now we drag the rotate to in a instance 2 tab, and we go R, G, and B. Now we need the B to be 0. This is only RG. What if we go here and reorder, and we set blue to 0, and this is 32 RGBA. And now we are good, but let's go here, so plus. Okay, now let's see. We don't see the colors. Let's use a feedback. So we don't see the color, we don't see alpha, and let's see why. So I will go into the network here, because this geometry now has a Fong1. Okay, so what if here in the render we say Fong1? Okay, now we have colors. What else we need to, oh, let's go back here. So now we can place this over our colors. Okay, and there's no alpha, right? Let's see. Let's go for the colors and alpha here. And right now nothing happened because alpha is 1, but let's use something else for the colors. Okay, so I'll have a noise which is RGBA, not monochrome, and those I want to have for the colors. Okay, let me make room. Colors goes here. Okay, and now let's use a level, and in the RGBA high alpha let's set to 0, 1, and yeah, this is good. We have the colors, but each line it's having a different color, and this is because we want to select what we have here. So select again from this texture, right? And then we connect to second input, and now we have the same colors for the lines, or similar colors. Okay, now it seems not. In this case, what I like to do is nearest pixels everything and check again. Yeah, we have something. You see those little points that are, and let me check this. So the sensors. If I change the distance for the sensor, I believe we can get rid of those. Oh, not quite, it seems, and I'm not sure why is that. I try to connect from this feedback now, and yeah, this is quite strange. I will pause this till I find the real reason. Okay, so I'm back. Yeah, I believe I know what was the reason for this. So first of all, here you might check this this geometry. Some lines go outside of the plane, and this might help if you set the up vector. Okay, so constant with 0, 1, 0, and yeah, this is the up vector. We say rotate up. Okay, and this also, the noise for the colors was set to input plus noise. It's only noise. Okay, so let's see now. They need to keep the colors, and yeah, it's pretty good now. I think this is correct. We can always play with this threshold, okay, to or the noise, and yeah, the colors are there. Now this is good. We're getting closer. Now let's bring back this. Yeah, let's see now a higher resolution, like 720. And sometimes this preview image, it's hiding some of the lines, or because it's a different resolution. So let's see how big is the file. This one, right? And yeah, you can see much better on this this resolution. And again, you can play with the alpha even more, or reduce it from the material, and play with the noise for more colors. What I like to do is use another noise, like this, and yeah, maybe I have plus 1 divided by 3. So I will have some variation for the colors, and that produce some nice shading. What else? You can play with this without the stepping angle. Okay, then you'll get some organic leaves or something. Also, you can play this noise. And yeah, they start to curves, and this is quite nice. And yeah, this was my tutorial, and I really hope you like this. If so, hit the like button, subscribe if you haven't already, or you can tell a friend if you really like this video. If you want me to go on and want to support me, you can do it on Patreon. You'll get access to a bunch of other tutorials, some of them more advanced, some other much easier than this. And yeah, I want to thanks to all my Patreon, and I'll see you in the next one. Bye.